Hi guys, Mr. G here. We are looking at the grade 10 past paper from 2016. This paper one, of course, and we're currently doing term 1 revision, which is mainly algebra. So without any further ado, let's get into this. So I've got the first question as usual. 1 point, you'll always have to factorize, and you've got factorizing by highest common factor, and I've told you guys about DOPS, a difference of perfect square or two squares. I've told you about grouping, and again there is sum or difference of cubes, okay? And yeah, that's just basically what it is. In this case, there isn't much to do. This is a binomial. So if it's a binomial, either we can use highest common factor or we can use DOPS or sum of difference of two cubes, but this is a square, but that's not a square. So actually highest common factor appeals more here. So this thing, you can see why it is 1 mark, all right? Then here, we've got to do a little bit of grouping. You can start right away with what you have here. Okay, you can see there's a 3, there's a 3, there is an x squared, there is an x there. So that means in terms of picking up the highest common factor from this block here, you can say x, 3 first, and then you are left with what? The x squared, and then you are left with px here. But you can see x appears in both, so this becomes x, and that becomes plus p. And as I said, guys, once you have your first group, whatever is left in the brackets tells you by fire, by force, you must have that in the other bracket, okay? So what you've got to do now, you've got to ask yourself, okay, I've got an x there. Where's the term that had an x? Is this one. So how does this thing differ from that? In other words, what's missing here, okay? What's missing here, and it is there, you can see it is minus 2m. There it is, minus 2m is exactly what is missing. So I've got to put a minus 2m here. And guess what? This minus 2m happens to be the exact same thing that is also missing here from the p. So you've got your factorization all nice and done. So this should now be x plus p into 3x minus 2m, and your 3 marks is in the back. This one here, guys, I will start by taking out the highest common factor so that I can use, well, I can simplify the thing for myself. So you can see 2 can go into 2, and 2 can go into 2, and 2 can go into 12. So I'm going to factor out 2 first so that I'm left with p squared minus p minus 6. And this thing simplifies to 2. Now, how can I factorize this trinomial? It's all nice and easy. P minus 3 into P plus 2. And that's it, 3 marks in the back. One thing that I should maybe mention here is that in 2p squared minus 2p minus 12, it's an expression in this case. There it is. But if this was an equation, then really it wouldn't matter whether I take out the 2. Actually, what I would have done instead of taking out the 2 is to just divide throughout by 2. Then I'll be left with p squared minus p minus 6 equals to 0. Because here now I will be solving for p in an equation. Okay, so that's the difference between having an equation and an expression. When you have an expression, you factor out and you keep the factor that you have factored out. In an equation, as long as you do the same thing on both sides of the equations, then all is good. So now finally, let's do this ones here. 2 to the exponent of a plus 1 minus 2 to the exponent of a minus 1 all over 2 to the exponent a. This here, guys, wants you just to do the reverse of law number 1 of exponents. So I'm going to break this into 2 to the exponent a and times 2 to the exponent 1. And then the same thing here. I must be careful. This one should be 2 to the exponent of minus 1 all over 2 to the exponent a. Now, if you remember the invisible math that we do, that thing there is 1, and this thing here has a coefficient of 1 as well as a product. Okay, remember we said in maths, every number, literally every number, is actually a product. Okay, so you can see now that there is something that seems to be common in every term here. and that is 2 to the exponent a. So that means we can factor that out. So this will be 2 to the exponent a. What's left there is 2 to the exponent 1. What is left here is 2 to the exponent of minus 1. And this is what's left here is a 1. And then you can see your favorite part is scratching stuff out. And then I'm dividing by 1. It just doesn't make a difference. So I'm left with 2 minus 1 over 2. And you can definitely write this as 1.5. And really, that's how easy this stuff is, guys. I'm sure you're loving it. Finally, let's get to this. X squared minus x plus 1 all over x cubed plus 1 divided by 2x over 2x plus 2, right? So you're going to start, of course, you know it's algebraic fractions. In this case, we are not adding the fractions, we are actually dividing the fractions. So you know there's got to be some cancellation happening there. Yeah, division, really big time. So what you want to really do is to factorize every term, okay? You're going to go to your numerator, factorize denominator, do the same thing, factorize, okay? But what you realize is you kind of starting with a lockerhead here because x squared minus x plus 1 does not seem to be factorized. And this is the reason. If you look at b squared minus 4ac, what we call the discriminant, this thing is actually now, you're going to have minus 1 squared, you're going to have minus 4 into 1, and c is 1. And this thing simplifies to 1 minus 4, which is negative 3, and negative is 0. Negative 3 is less than 0. So this tells us that actually this thing, if you're going to factorize it, it cannot factorize into real roots. The numbers will not be real, okay? If this is actually a parabola, and if you're going to sketch this parabola, it's going to be somewhere above the x-axis. There's no way it's going to cut the y-axis. That is what really we are getting out of this. Okay, so this cannot be factorized. And so we're going to leave it as it is, hoping that it will divide with something at some point. Actually, it will. Let's see where. So there I am. What is this? Sum of two cubes. Remember the square and sum. So how do we factorize the sum? If I have a cubed plus b cubed, this thing will be a plus b, okay? In my brackets, I know first time I'm going to have a squared, and then I'm going to have plus b squared. Now here I'm going to have a product of a and b. And if the sign is positive here, that should be negative. And it's the same thing, guys, for the difference of two cubes, really. You're going to have a minus b first, then you're going to have a squared, you're going to have b squared here plus, now you're going to have a product of this two, which is ab, and if that thing is a minus, then this thing has got to be plus. That's how easy you need to remember this sum and difference of perfect cubes. Okay, so let's get to this and factorize. So now that you have seen how we're going to do this, so it's very nice and easy. This has to be x plus 1 into, I must have an x squared here, and I must have a 1 squared there, plus, as a matter of fact, the product of 1 and x is just x, and because that's a plus, this thing here has to be a minus, and you can see why this thing was not factorizing. It's because this thing here will take care of that. And now, of course, I've got to move on. In this case, I am not going to use the division sign. I'm going to use the multiplication sign, and I'm going to take the denominator up there, and I'll factorize it right away so that I have 2 into x plus 1, and down here I have 2x. Okay, don't forget your equal signs there, and be mindful of how I put my equal signs. I do not have double equal signs. Okay, so now I know this thing takes care of that thing, and because everything is a multiple, okay, it's a product rather, then I can just do this. Okay, and then I'm left with 2 over 2x, and this thing here is actually 1 over x. Okay, guys, I could do this because the terms really, I've got one term in the numerator, one term in the denominator. Okay, it's a different case if I had x squared minus 1 over x squared plus 1. Guys, I cannot I cannot do this. I cannot. Please stop killing kittens, right? I cannot do that. That is illegal. Okay, you've got two terms and two terms. You don't have a product there. So please be mindful of such things. Okay, that's about it from me, folks. I hope you've enjoyed this and you have gained some light and insight into your mathematics career. Keep on practicing, keep on doing those problems. I wish you nothing but the best. Take care.